The next thing I'm going to be talking about is the derivative of logarithms, in particularly the natural logarithms. Yeah. The first property is that the derivative of ln x is equals to 1 over x. We're going to use chain rule heavily here, so you need to pay attention and you need to be familiar with how chain rule works. Okay. So let's say, for example, the next example is ln of 3x. Find the derivative of that. So to do this, you have to look at the inner function. The inner function is 3x. So you derive that first, giving you a 3. And then, looking at this format, then the other one would be, the outer function would be 1 over 3x. This will give you a 3 over 3x. It will give you a 1 over x. How about ln 100x? Again, 100x is your inner function. You derive it first, then you'll get a 100 here. And then the outer function will give you 1 over 100x, and that will still be 1 over x. So in conclusion, the derivative of ln of ax, any value of a here, you will always get x, where a is real. Okay? Alright, next up we got ln of 3x plus 2. Yeah. So again, we will still gonna use chain rule. So that means that, hey, what is 3x plus 2? The derivation of 3x plus 2, it's gonna be 3 times the outer function, which is 1 over 3x plus 2. So that's gonna be your answer. This one, you have to be careful because the coefficient of x is negative here. So you have to do something about it, right? So the derivative of this is going to be minus 2 times 1 over 3 minus 2x. So the answer would be negative 2 over 3 minus 2x. How about if it's a square? Yeah? And when I say ln x squared, I mean I square the x. Yeah? So how are you going to be able to find this? Still, you will use chain rule. And one way of doing this is using chain rule, actually. Yeah, you make this as your outer function, inner function. You'll get a 2x when you derive this, and then you multiply by x squared, giving a 2 over x. Yeah. I mean, another way of doing this is, hey, this is the same as. So that's gonna be the same thing. Okay? This one, again, use chain rule. The inner function, you derive it first. You got 6x minus 5 here, divided by 3x squared minus 5x plus 2. That's going to be your answer. As easy as that. Once again, when you're trying to perform a differentiation in logarithms, you need to be familiar with chain rule. Yeah? The one of your inner function, you derive it first, and then you use the same format. Okay, 2 examples here, application examples. First is, you got the function y equals to 2x squared minus ln x, where x is positive. The question here is to find the stationary points and determine the nature of the stationary points. So to solve this, again, when they say to find the stationary points, the first thing you need to do is to make dy dx equals to 0, right? Okay, so this implies, if you differentiate this, you'll get a 4x minus 1 over x equals to 0. Yeah? This will give you a 4x equals to 1 over x. Yeah? So x squared is equals to 1 over 4. So x equals to half, and or x equals to negative half. So when x equals to half, what is your y? Your y would be equals to 2 times 1 over 4 minus ln half. Y equals to half plus 2 ln 2. Sorry, ln 2. So therefore, this is the first stationary point. when x equals to negative half, y equals to 2 times 1 over 4 also minus ln negative. Is there any ln negative? There's no ln negative, so we're not gonna use this at all, yeah, because this is totally wrong. Okay, so coming back again to this, so that's gonna be your only stationary point. So how do you determine the nature? Well, you just do the second derivative, yeah, to determine nature, you do second derivative. D squared y over dx squared equals to what? If your dy dx is 4x minus 1 over x, or this is going to be x to the power of minus 1, right? So what's your d squared y over dx squared? You differentiate this a little bit more, you get in 4 minus, that's going to be plus x, right? Plus x to the power of minus 2. Yeah. And you put the value of x here, yeah, at x equals to half. So d squared y over dx squared equals to, that's going to be 4 plus 1 over x squared, 1 over 1 over 4. That's going to be positive, right? Whatever that is. So therefore, it's minimum. The second application question is, find the equation of the normal at x equals to 2 to the curve with equation y equals to ln 2x minus 3. So one thing to recall of paper 1, equation of the normal, you have to remember that the m of the normal times the gradient of the tangent line, that has to be equals to minus 1. You have to remember this, yeah? That's part of your paper 1. So, okay, let's go back to the question. Find the equation of the normal at x equals to 2 to the curve with equation y equals to ln. So first thing for us to do is to find the dy dx. Because the dy dx, according to our paper 1, dy dx is your gradient, right? The gradient of the tangent line. So dy over dx is equals to, well, there's going to be 2 over 2x minus 3. At x equals to 2, so your dy dx now is equals to 2 over 4 minus 3, which is equals to 2. So that's your gradient. The gradient of the tangent line. So this is going to be the gradient of your tangent line. So therefore, the gradient of your normal times the gradient of your tangent line is equals to minus 1. The gradient of your normal is equals to minus 1 over the gradient of your tangent. So the gradient of your normal has to be equals to negative 1 over 2. The equation of the normal at x equals to 2. So therefore, that's gonna be a straight line. So y equals to mx plus c is the format of answer that we're looking for, right? They didn't specify though, but you know, we're just gonna work from here. Y equals to mx plus c. We know that m is minus half. We know that x is equals to 2, but we don't know what y is, right? But you can always use the value of y here. So when you use the value of y here, you have to, you know, put a side note here. Y at x equals to 2 is ln 4 minus 3 ln 1 0. Yeah, so y is equals to 0. So the coordinate is actually 2, 0. So that's going to be 0. So your c is going to be equals to 1. So therefore, the normal would be minus, the equation of normal minus half x plus 1. And that's going to be your final answer.